Welcome to DIY Volts. I'm Seth. A friend of mine asked if I could help install off-grid solar for him, and so I have taken a few clips of the install for you to enjoy. Let's start off by talking about the solar panel install. We have two different arrays, and they are set at a degree of 31 degrees, and they are facing solar south. Now, to get that angle, I used an app which showed us the exact location where the panels should go. Basically, the app will rotate up and down and left and right to find that exact position. Now, the rocky soil here is very difficult to dig into, so four of us had post hole diggers and a pry bar, and we pulled out so many rocks in this little area. So our mounting system wasn't 100% straight, but we managed to get by with the unistrut being able to mount a little further up or a little further down in order to get the panels in the right position. So the total number of panels we have is 24 panels for a total of 10 kilowatts of solar power. This has been more than enough. My friend has had his solar installed for a couple of weeks now, and the battery has not dropped below about 90% so far, and he is very happy with that. So as far as the installation goes for the panels, we dug all the holes, which was 12 in total, and then we sank either 6x8s or 4x4s, depending on what my neighbor had around his property. And then on top of those, we then used a 2x8. Now that is treated, of course. And we used a bunch of lag screws that he already had around the property, and they needed washers to prevent them from going through the wood or the unistrut. Now the unistrut is a product that was picked up from Home Depot, and the price has gone way up, but it is still an effective way of mounting these panels. So essentially, big washers are used with those lag screws to go into the 2x6 at just the right separation for the panels. The distance between each panel was mounted at 42.5 inch. Now you'll see that we mounted these panels in more of a vertical fashion. In the past, I've mounted them in a horizontal direction, but that wasn't going to work out because the unistrut is only 10 foot and the panels would have been off the top of that. So we turned them into the vertical position, and it worked out quite well.
Topping first. Yeah, that gonna be less, a little bit less. Maybe I get it in a minute. I don't know. That pulled it. Well, it pulled it down.
As far as wiring the panels goes, they were done in series, so positive to negative, positive to negative. So in the end, we had one overall positive, one overall negative per array. So 2 of those total. Also, a ground rod was put in the ground, and then each panel was connected by a copper wire and also a couple of screws. I did use a multimeter to make sure that there was continuity between each panel, and so everything was grounded proper. So because we have 2 arrays, we needed to run 2 sets of solar wire up the hill. I used 10 gauge, and it is direct bury. And so that was sent up the hill. Like I mentioned, we didn't quite get our post set straight in the ground, and so you'll see there is a separation between these 6 panels and these 6 panels, and an offset right there in the middle. And sadly, the same thing happened back here on the back for the second array. We have a separation right here in the middle. So because the 2 of them are the same, it looks like it's done on purpose, although I would have liked to have had them evenly spaced all the way across. So as far as the ground goes, you step up under here, you can see we've used the ground of this panel right here with a big copper wire that goes down and is mounted right here to the ground rod. It goes 8 feet into the ground. Now each panel is then linked together with ground right here over to this one, and we're using the unistrut here as the connection point between the top set of panels and the bottom set of panels. As you can see, positive to negative all the way across the bottom, and then I was able to keep these zip tied together up here for positive negative. If I had realized, I could have reversed the bottom panels and it would have been like this on both the top and bottom, but because I didn't do that, we had to cross over positive negatives down there. All right, and that's the basic install of the panels down here. Let's move up to the electronics and I will show you all of that. My neighbor has an excavator and a skid steer, and so he was able to dig the trench for the solar wire using the excavator, and he was also able to move the batteries with the skid steer with forks on the front. Made the whole process much easier of getting the wire dug and the batteries moved. Here we have the electronics of this solar install. Now it's ideal to have the EG4 equipment, the inverter and batteries, to be covered, as you see here with this porch. It's also preferable to have them out of the sun, but this is the only place we could put them, and so they do see sun for a little while. The first part of the installation up here was to get the solar wire into a disconnect box. This box is rated for DC power and has a single throw to cut off both circuits or both arrays of solar. So the box is very small and it was tedious. I don't think I filmed anything in that because it was it took a long time, let's just say that. So after I got that done, it was time to install the batteries. Like I said before, my neighbor has a skid steer and he was able to pick up the batteries and move them into position. We used some gravel and a 2x10 to put the batteries on top of, and that kind of got us mostly level. The good thing is these batteries have adjustable legs, and so you can make them level after you've got them into position.
Don't you got to drill your holes for you do your brick?
Yeah, we got to see how that's done. But what we could do is we can get it up there and slide it over if we need to.
How much room left?
Well, we've got the whole of the box of these from the other battery.
Yeah.
I'll get one of those real quick.
Let's see if we can get it on there. If I can, we'll be fine. I'm gonna get it first. Now. We are now.
I think so.
All 300 pounds. Above the screw hole.
No, this goes on top.
Oh, okay.
And that way all of your cables will hide up in here.
Okay.
And they go through here into the inverter, and you never
Okay.
see anything. Gotta follow that arrow on it.
Down. That's down.
The arrow points up.
Oh, up?
Yep. The inverter will clip into this on the back. I made the same mistake with mine years ago.
Huh.
I think an arrow's supposed to go up.
It does. So with the batteries in place, we moved on to the inverter, and the inverter is a bit heavy, not as heavy as the batteries, but we were able to hoist it up onto the mounting bracket. Now the mounting bracket for both the batteries and the inverter, we used anchors into the wall. It's the kind of anchor that when you tighten it, it expands a metal sleeve inside the wall and makes a very secure fit. So essentially both of these use the French cleat style attachment. It's where you put the bracket on the wall first and then you just lift the battery or inverter up into position. Once the inverter and battery was set, it was then time to get the wiring done. Now I don't think that I filmed much of this because once again it's tedious and I'm not an electrician, but I will show you what I did here. The solar wire goes up into the inverter on the back side, and that is placed into the inputs I believe I used 2 and 3. Now you'll notice here that I have 2 surge protectors. These are the Midnite Solar 600 volt surge protectors rated for DC voltage. And these I just slipped directly into the solar input on the inverter. So once the solar is installed, I moved on to connecting up the batteries. Now we used the conduit boxes, and that really makes the install look nice and pretty. I'm glad that EG4 has done that. So because we have 2 batteries, I had to get one of the extension cables, or the parallel cables, and that goes from the battery that doesn't have the inverter on top over to the battery that does have the inverter on top. As far as the dip switches for which battery is number 1 and number 2, the one that has the inverter I named number 1, and the battery without the inverter is battery number 2. Now it's time to move over to the AC side of this install. First I installed a 60 amp disconnect switch, and then used some mobile home feeder wire to go from the inverter into the disconnect, and then from the disconnect into the house. From the AC disconnect, the mobile home feeder cable goes into the house into a transfer switch. Now the transfer switch is a 50 amp box that's going to allow basically 2 inputs. So you can either have the grid input or the solar input, and then feed the house that power. So essentially it is completely isolating the power from the grid, and that way there is no chance of back feeding onto the grid. A 2x10 was used on the bottom with some gravel to level out this surface. The legs have adjustable feet, and so you're able to turn those and level the batteries out quite nicely. On top of the batteries, the EG4 conduit box was installed, and that simply just keeps the wiring nice and tidy, as you can see. On the top of the battery number 2, I installed the rubber hole fillers right there to keep any bugs out of that. The battery cable goes over to the second conduit box. It's a bit more cluttered in there, as you can see, but basically you have the connector battery cable from battery number 2 in here, and then you've got the 2 battery cables going up into the inverter. You've also got the communications cable, and the wiring for the surge protectors is in there as well. But as you can see, when this closes up, it looks nice and pretty, and you can even lock these if you need to keep people from getting in there. Now, when it comes to the inverter, you've got the 2 solar strings, you've got the ground, the neutral, and the 2 hot loads from the AC power. You've got all the battery cables, and again, you've got the surge protectors as well. Now here you can see I've installed the screen. This LCD screen does not come with the Flexboss 21, but I feel like it's necessary. Sadly, they've not updated the firmware yet, and so if I click in here, you can see it says some weird numbers, like the house is using 22 kilowatts, and yeah, anyway, it needs to be updated. Although today you can see 4.6 kilowatt hours for a total of 63.5. So they've not used a whole lot of power yet, but they are definitely consuming. Yeah, so we only have 10K of solar, and right now it is showing that it's got 14 plus 11 coming in. So that is inaccurate. The EG4 system has an app which is pretty fantastic. It allows you to track the information coming in for solar and also what the house is using. And so this Wi-Fi dongle right here is connected to the phone to show the information of solar coming in and power going out. Thank you so much for watching this video on installing solar power for my friend. Between the solar panels and all the electronics, it took us about a week and a half to get all this installed. So it definitely takes a bit of time, but it is well worth it. We had a hurricane here back in September that knocked out the power for 18 days, and a system like this would have made their lives so much easier. If you'd like to check out the equipment used in this video, it's all from Signature Solar. So I will have links to that in the description down below. It is an affiliate account, so I'll get a small kickback if you order from those links. I'm Seth with DIY Volts, and I will see you in the next video.